And welcome back, everybody. Before we get into solving quadratic functions, we're going to talk about something called complex numbers and the imaginary number. So we said before that if we have an even root, like the square root of -9, we can't do that because the only way to get a -9 is a +3 times a -3, and those are not identical. So if only we could get rid of that pesky negative, we actually could take the square root. Well, guess what? Now we're going to talk about imaginary numbers, and with those, we can. What are imaginary numbers? Well, the square root of -1 is an imaginary number. It's imaginary because I can't plot it on any of the XY axes that we've ever talked about. So the square root of -1 is equal to I, and the square root of -1 squared is -1. Remember, squares and square roots are opposites of each other. They're inverses, they undo each other, and so that's -1. These two things right here, you need to memorize. You need to know them and be able to use them a lot. So please, please, please make sure that you memorize those. So now that we know that I is equal to the square root of -1, we're going to rewrite the square root of -9 as the square root of 9 times the square root of -1. So what is the square root of 9? Well, it's 3. The square root of -1, well, we just found out that that's I. So our answer would be 3I. So let's try a couple of problems. The square root of -25. Let's rewrite that as the square root of +25 times the square root of -1. The square root of 25 is 5, and the square root of -1 is I. So our answer would be 5I. The square root of -64. We'll change that to the square root of 64 times the square root of -1. The square root of 64 is 8, and the square root of -1 is I. In our last example here, the square root of -49x squared. So we can rewrite that to 49x squared under the radical times the square root of -1. The square root of 49 is 7. The square root of x squared is x. And the square root of -1 is I. So our answer there would be 7xi. So now on to complex numbers. Complex numbers have a real part that I can graph, I can manipulate actual numbers, and then an imaginary part. The format is A plus BI. The A, like this -2, is the real number. The plus 3I is the imaginary number. Here we have the 4 is real, the 7I is imaginary, 4 is real, the -I is imaginary, the 6 is real, the -9I is imaginary. Well, of course, as with any other things with variables and numbers, we can do operations. So we're going to start with adding and subtracting these complex numbers. Adding and subtracting complex numbers are just like adding and subtracting like terms. If I was X or A or B, the only difference is that I is a specific equal to square root of -1. So if I'm looking at example A, we have -3 plus 5. -3 plus 5 is 2. And then 4i plus -I is 3i. And that's it. We can't go any further because the 2 and the 3i are not like terms. The 2 is the real, the 3i is the imaginary. Example B. Before I get started on example B, I see this subtraction sign right here in the middle. And one thing that I like to do so I don't forget about the subtraction is I think of this as a -1. And I'm going to distribute that -1 on the right side to the 7 and the 2i. So that becomes a +7 and a +2i, and now I'm adding in the middle. Now my like terms are 4 plus 7, which is 11, and -3 plus 2i is -1i. And so that would be my solution for example B. Again, for example C, I'm going to distribute this -1 so that I have the left side staying the same, -6 plus 15i, plus -1 times 3 is -3, and -1 times -22i is +22i. Now I'm going to combine my like terms. -6 plus -3 is -9. 15i plus 22i is +37i. We're going to pause our notes here, check through everything, and when you're ready, click on 3.2 Notes, Part 2 to continue the rest of tonight's notes.